Hi guys, welcome back to EPS. It's Mr. Jones. Today we're going to talk about unit conversions. We're going to start out with some SI prefix conversions where we're just changing the power of 10 to express the same amount in just a different way. So we have to manipulate the number to match a new unit. We're also going to talk about dimensional analysis. Seems kind of scary, but we're just going to change the dimension of a number. So we might be going from English to SI, so from maybe inches to kilometers or something along those lines. First thing is SI prefix conversions. They're really pretty simple. If I want to go from meters to kilometers, or if I want to use some that are less familiar, like micrometers to picometers, how can I go from one unit to the next by just changing the power of 10? Well, it's not too bad just to think about, okay, I just need to move a decimal in the end. It's just a power of 10. But how do I do it? Which direction do I go? That's really the thing that perplexes students the most. Okay, where do I move the decimal? To the right or to the left? Well, I'm going to make it really simple. All right, think about this example. 532 meters, how many kilometers is that? Well, I think of a balance in my head. I think about the size of the number and the unit, and I think about the unit that I'm going to express it in. Okay, so if we think about our problem solving steps, I identify my starting information. I'm going to think about where's my ending information. Okay, once I get a plan, okay, which way do I go? How am I going to get there? And then finally, can I evaluate my answer and see if it's practical? So 532 meters, how many kilometers is that? So if I think about these, they're relatively basic size units and basic size numbers. So 532, not too big, not too small, and a meter is a base unit. You'll notice there's no prefix in front of it. Okay, if I compare that to a kilometer, well, I know a kilometer is bigger than a meter. Well, how much bigger? Well, one thing I can do is I can look at my green sheet or my conversion chart, and I can see the difference. A kilometer is actually 1,000 times bigger. Since a meter is a base unit, it's just 10 to the 0th. A kilometer is 10 to the 3rd. So that's a difference of 3. So I just need to move the decimal. So think about it. My number, okay, will it get bigger or smaller? Okay, I'm starting with a unit, and I'm going to go to a larger unit. So what's going to have to happen to my number in order to keep this balanced? Well, my number is going to have to be smaller. Okay, so I moved the decimal 3 places, and the answer is 0.532 kilometers. So using our green sheets, we can actually just write this down. You can actually have this on your sheet that we can use for testing quizzes. Anytime I go from my lower unit, if I think about going from a milli to a kilo, I just have to think, wow, a millimeter is pretty small and a kilometer is pretty big. So if I'm going to express a bunch of milliliters in kilometers, it doesn't matter how big it is, it's probably going to make that number really small. Okay, so milli is 10 to the negative 3rd, kilo is 10 to the 3rd. If I think about the difference in math, I'm going to subtract. So that's actually a difference of 6. I'm going to move the decimal 6 places. Well, which direction? I'm going up, so I'm going to move it to the left. And the same thing goes for when we move down units. Okay, if we went from deci to micro, how would we move the decimal? Well, we move it to the right. We just need to do a little subtraction to find how far. All right, here's a bunch of examples. I usually like to do these in class on whiteboards. Okay, do a little practice moving it from one to the other. Sometimes I have you guys do it on your own, and sometimes I really go through step by step. What are our units and what is the value of their exponents? What factor are they raised to? So a centimeter is actually 100th of a meter, or 10 to the negative 2nd, while a meter, if we notice there's nothing in front of it, it's a base unit. So anytime we have a base unit, like a meter or an amp, those are just SI units that we use as base measurements. So they don't have anything in front of them, so they're always 10 to the 0. And that's what it says on your sheet. Your green sheet, it just says base unit. Okay, if we think about these centimeters to meters, okay, 20 centimeters, well, if I think about a meter stick, 20 centimeters isn't that much of it. Okay, maybe you think about the fraction in your head or something like that, but I just think about moving the decimal 2 places. Well, I'm going from a smaller unit to a bigger unit, so 0.2. And the same thing goes for the following examples that we'll do in class, or you guys can think about them on your own. So you can pause the video, or you can just watch and follow along. But it helps to really do the practice. Okay, from 0.032 amps to milliamps, okay, we have to go down. How many spots? 3 spots. And the same thing is true for number 3, 45 micrometers, and we want to go to nanometers. 2 less familiar measurements, they're used for really, really small things. Okay, bacteria, protists, things like that, things that we can't see with our eyes would be measured in micro and nanometers. So think about the difference in the units. Okay, -6 and -9, that's a difference of 3. Okay, a micrometer is bigger. Let's move it to the right 3 places. And you guys can do the last one. It's actually 4, a negative and a positive value, a -1 and a positive third. That's a difference of a factor of 4. So we'd move the decimal 4 places. All right, the next thing we're going to do is talk about dimensional analysis, sometimes called the factor label method. My high school teacher called it railroad tracks. They maybe look a little bit like that, I don't know. Okay, what we're going to do is similar to a density problem. We're going to think about, okay, what information is given to us, how can I cancel out the units I don't want, and get to an answer that I guess we can evaluate and see if it makes sense. So just like when we found mass from when we're given a density and volume, we can factor out the units that we don't want. So if we took a volume, times a density, we can easily see that the number on top in the numerator can cancel out with the, number and unit in the bottom, which in this case is centimeters cubed. So in this case, let's just talk about the units. Centimeters cubed would cancel out with the centimeters cubed on bottom. We'd be left with grams on top, which would be appropriate for a way to measure mass. All right. The new problem-solving steps. So you'll notice that with a bunch of different processes in this class, we're going to follow steps for solving. And they work all the time. So it depends on sometimes 3 variable equations. We'll use one set of problem-solving steps. They still have the same basic principles, but we have to think about the different factors that it takes to solve each type of problem. So that's kind of what we're doing here at the beginning of the year. Okay, first thing we want to do is identify our starting quantity. Remember, a quantity is a number and a unit. So it's going to be basically the thing in the problem that's given to us. Okay, it's usually going to have a number and how is it expressed? What unit? And we're going to bring that to our ending units. Okay, and that's usually going to be, okay, we start with 15 inches. How many centimeters is that? Well, how many steps will that take us? Okay, that's where we plan. We want to line up conversion factors. Okay, and a lot of times we turn these into fractions. We can look at different conversion factors on our green sheet and turn them simply into fractions so we can cancel out unwanted units. The next step is to execute. We're going to multiply all the top numbers. We're going to divide by the product of the bottom numbers. So we need to have the product, which means if there's multiple numbers on the bottom, we should, multiply them together and then divide them by whatever we got on top. Okay, if we do it, one step at a time, we might, lose our order of operations. So there's a couple of ways to do that. And we can talk about those in class. But remember, we're going to multiply all the top numbers and divide it by the product of the bottom numbers. And then finally, most importantly, do not forget to check your units and evaluate your answer. Think about, where does my answer need to go? Should it get bigger? Should it get smaller? And do the units make sense for what we're measuring? Simple way to set up conversion fractions couldn't be any simpler. Okay, if we know a fact is an inch is equal to 2.54 centimeters, we can simply set that up as a conversion fraction by setting it equal to itself and dividing. So a little bit of algebra that's really not that important. Just know that it works. Okay, so if we set up this little equation here and we can cancel out the factors we don't want, we know that this is equal to 1. The same is true for the vice versa. We can make a fraction the other way with the 2.54 on top rather than the inch on top. And that's how that works. Here's your charts. Okay, you'll notice these on the back over here. Remember, we could put those arrows for which way to move the decimal left and right. Okay, over here is going to be a good list of different types of English to English, SI to English, SI to SI conversions that'll be very useful in this class. Okay, the first one I like to start with is just a simple inches to centimeters, because a lot of people can do this one in their head. They're usually pretty familiar with this from previous years. They have an idea of what an inch and a centimeter is. So I usually start out with an easy question like how many inches are in this many centimeters, or vice versa. And I usually get a lot of success on students telling me that. Well, we can also set up a problem-solving process to do that just as easily. So European hairdresser is going to cut off 8 centimeters of hair. How many inches is that? Well, maybe you'd want to know. Maybe you don't want a bunch of your hair hacked off. Okay, so problem-solving steps. What do we know? What can we identify? 8 centimeters. Where do we want to go? We want to end up in inches. Okay, this can be an easy one-step conversion. We're going to start with our given quantity out front. Okay, it's a quantity. It has a number and some units. Okay, now we're going to go ahead and put our fraction in. Well, we know that there's 2.54 centimeters in an inch, or vice versa. In 1 inch, there's 2.54 centimeters. If I want to get rid of centimeters, I should put it on the bottom. So a lot of students already know we should divide. Okay, but we also have to think about if we have more than one step, we want to multiply across the top. So this one's pretty easy. 8 times 1 is 8 divided by 2.5. And a little bit of evaluating in my head, tells me that, oh, 3, maybe a little bit more, okay, and it ends up being about 3.15 inches. Okay, the next problem has 2 steps, okay? This has to do with starting with one dimension, bringing it from English to SI, okay, and then from SI, we want to convert it into a different unit of SI, okay, so we don't have a direct conversion between milliliters and quarts. Watch out for that, okay? How many milliliters are in a quart of milk? Okay, so let's pretend they sell milk in quarts. Usually we do gallons and half gallons and stuff like that, but let's imagine a quart. Okay, what's one thing we can figure out? Well, we have an analogy between quarts and liters, but not one between quarts and milliliters. So we can do a couple different ways of solving this. In this case, I just like to use my railroad tracks, if you will, to just solve it in 2 simple steps. I'm going to start with my given quantity. Okay, that's my quart, and I'm going to go ahead and first convert that to liters. So if I look at my sheet, I can see that there's 1.057 quarts in a liter, or vice versa. Well, I want to get rid of the quarts, so I put that part on bottom. I notice those units cancel out. If I wanted to stop, this would tell me the answer. Okay, I would know right now how many liters there are. But that's not what the question's asking. The question is asking for milliliters. So some of you guys, if I ask you in class, some kids can figure it out. They think to themselves, a quart and a liter are about the same thing. So if I can divide by the conversion factor and then, move the decimal place, I'd be good to go. And you're right. But another thing we can do is just set up another step in our conversions. Well, how many milliliters is in a liter? Well, if it's a factor of 10 to the third, that means there must be 1,000 milliliters in every liter. Okay, and you guys can see that by the example on your chart. It gives you an example, I believe, with, meters. But we could plug in any quantity that we wanted, okay, to find out what the equivalence is. And in this case, it's 1,000 to 1. Well, I want to get rid of the liter, so I want to put it on bottom. Now it's simply a matter of multiply the top, divide by the product of the bottom. 1 times 1,000 is 1,000. And this just over 1 times 1 is, just over 1. Okay, so it's maybe a little bit tough to do in our head, but we can evaluate a little bit. 1,000 divided by 1 would be 1,000, so divided by a little bit more than 1 would give us a little bit less than 1,000, and it ends up being 946 milliliters. Okay, I always like to have students kind of do a couple on their own. I think part of the process of science is to struggle and think ahead a little bit. Can you add another step? So a lot of times kids, they feel a little bit lost at first because sometimes I throw you out in the water and I say, hey, can you figure out this problem? Then if you follow the process, you'll notice it's a lot easier. Okay, so here's the next problem. Assume your mass is 55 kilograms. Sometimes I wish I was 55 kilograms, but I'm well beyond that now. How would I know how many pounds I weigh? Well, it's a simple one-step conversion. So stop, see if you can do it on your own, and then finish the problem. Did you get it? All right, so we want to go from kilograms to pounds. 55 kilograms, there's 2.2 pounds in a kilogram, but I want to get rid of the kilogram. And one thing we always got to do is make sure we keep the right quantity with the right number. So on my sheet, it says 1 kilogram is equal to 2.2 pounds. If I want to cancel out kilograms, I better make sure I don't put 2.2 kilograms on the bottom. That would not be true about the conversion between kilograms and pounds. It's always 1 kilogram to 2.2 pounds. A simple one-step problem gets me to this solution, 121 pounds. Okay, there's a couple more examples in your notes that you guys can use to find out how many feet are in a 5K race. So if you've ever ran a 5K, okay, that's just a 5K is a fancy American way of saying a 5-kilometer race. Some people